Previously, we showed you a postage stamp of Isaac Newton, the British mathematician that is one of the founders of calculus. Well, in this lesson, we have another postage stamp from Leibniz, the German mathematician who discovered calculus at the same time that Newton did. So Leibniz and Newton were contemporaries. They both discovered calculus around the same time. But I think it's interesting in this postage stamp, this little diagram right here looks a lot like what we were doing over here when we were deriving the slope of the line tangent to the graph. Okay, so in this lesson, we want to look at functions that are products of other functions and functions that are quotients of other functions. And we want to look at how to find their derivative. Now we know how to differentiate this function, we know how to differentiate this function, so we could just multiply these out and get a polynomial function that we could differentiate. But we're going to have a lot of situations like this, and it would be better if we didn't have to multiply everything out each time to apply the derivative. So what we need is a rule that allows us to differentiate any function that's the product of two other functions. And look, the rule is kind of interesting. It turns out to be this. If I want to differentiate the product of u and v, where u and v are both functions of x, that derivative of that product is going to be the derivative of the first function times the second function plus the derivative of the second function times the first function. So this is the formula we're going to use in this section to find derivatives for functions that are products of other functions like this. Now we're going to have another rule for the derivative of a quotient. It's going to look kind of similar to this one, but in any case, it's not maybe the way you intuitively would expect it to be. Just the derivative of this times the derivative of that. It never works. It always has to be this. Derivative of the first times the second plus derivative of the second times the first. That's the formula for the derivative of a product of two functions.